So we've now got a region that is bounded by this function y equals 3 square root of x over 4 by the x-axis and by the line x equals 4. So we should probably draw in that line x equals 4 that we're bounding also. All right, so this is the region that we are talking about. And we're going to take that region and we're going to revolve it not around the x-axis, but around the line. And I've written x equals 4 here, but I want to switch this up. We're going to do x equals 4 in a minute. I want to revolve it around the line y equals -1 first. Okay. So what is the line y equals -1? Well, it's just the horizontal line that's right here below the x-axis, right? Everybody agree with that? So what happens if I revolve this around that line? Well, I'm going to get a sort of, it's like a washer sort of type thing, right? Except that it's got this like three-dimensional whatever, it's like a bullet, the end of a bullet, but it's got a hole through the middle of it or something like that. True? You all agree with that?
Yes, that would be.
Yeah. Yes.
So the question then is going to be, how do we find this volume? Well, what do the cross sections look like?
Circles, right?
Oh, not quite
like
circles.
a washer circle.
Like a washer, right? So all we need to do is do pi times the integral from the furthest left, 0, to the furthest right, 4, of the outer radius minus the inner radius. Well, what's our outer radius? Our outer radius should be not just this value of y, but it's the value from the line we're oscillating around, right here, right, all the way up to y. So capital R would be our outer radius. And so what is that radius? It should be
The function +1.
right. It should be 1 plus 3 root x over 4. So that's our outer radius. And we're going to square that, right? Capital R is 1 plus y, or 1 plus that function. And what's the inner radius? The inner radius, the smaller circle, is just the gap in it, right? It's just this value between the y-axis and -1, which is just 1 unit. Everybody good with that? Or
Wait,
no?
why'd you put dy if the rest is in terms of x?
Oh, I don't know. Good question. dx, sorry. I don't know why I put dy, just out of stupidity, I guess.
So the smaller radius is 1, isn't it a half?
No, because we're revolving around this line. There's a gap,
Oh, right.
and so then there's that same amount of gap below also.
Gotcha. Yeah. Okay.
Okay. Everybody good with this being a setup to find that? Or no?
Yeah.
Okay.
So it's just similar
Yeah, it
to
works for
the
me.
washer problems, but we're just adding like we're not revolving around the x-axis anymore, right? That's all the difference is, right?
Exactly. And so
Okay.
this is not an integral I'd make you solve on your own, probably. So if you wanted to, you could approximate this on your calculator. But the most important thing is that you can get this set up. Okay. That's what I want. Everybody okay with that setup? Everybody understand how we got that?
Yep.
Okay, perfect. We're going to do another one. We're going to come back to that from that we were supposed to do in a little bit. But let's suppose we had this function. We're just going to call it y equals root x because that's just simple. Okay. From, doesn't matter, x equals 0 to x equals 4. Okay. And let's say we wanted to revolve it around this line, y equals -5. Okay. What would that end up looking like? It'd look very similar to the last one, right? Except we just have a much bigger gap here, wouldn't we?
Yeah.
And so what would this look like? This should look like an integral with pi out in front from 0 to 4. And what is our outer radius going to be this time?
The function +5, right?
Yep, this distance here is 5, and this distance should be y plus 5. So it should be 5 plus root x squared minus, and what's our inner radius?
Just the 5.
5 and then squared dx. And once again, I'm not going to bother to go through and do the evaluation of this. We should by now be fine with doing integrals in general. This one is one you should be able to do on your own. You just expand it out, combine your like terms and integrate. It shouldn't be that difficult. Okay. But everybody okay with that setup?
Yeah.
Yeah, it looks good.
Great. All right, let's do another one. Let's take a look at, let's say, why not? We'll just do, it doesn't look like root x. Let's just do root x again. But this time I want to revolve it around the line y equals 3. And so let's just cut this off here at 4 again. So I want to revolve this around the line y equals 3, which is going to give me something a little different looking, right? It's going to be like this up here, right? The cross sections are still going to be
The washer things.
still going to be washers. But now, what's our outer radius and our inner radius? This line that we're revolving around is the center of the hole in the middle of it, right?
Yeah.
And so how far down do I need to go for this outer radius? From y equals 3, I need to go all the way down to
0, so 3.
right. My outer radius should be 3. So it's pi, an integral from 0 to 4, an outer radius of 3. And what's our inner radius then going to be? Our inner radius is affected by the value of the function, right?
Yeah.
This is our inner radius. Well, our inner radius should be
3 minus the function.
exactly, right? This whole thing is 3. This piece of it right here is y. So it should be 3 minus y, or 3 minus root x. And we got to square that dx. Good or no?
It's good.
All right. Let's do one more. Everybody's good following along with that?
Yep.
Yeah.
All right. Let's take root x. This time we're just going to go from 0 to 1. And let's take x squared plus 1. Okay. So we're going to take this region between root x and x squared plus 1 and revolve it around y equals -1. And once again, that should give us these washer cross sections, right? So we're going around y equals -1. So we should have pi times an integral from 0 to 1. What's our outer radius?
Are we just revolving the region between?
Yeah, the region between them
Oh,
around
okay.
-1. Yep.
It would be, would it just be like the upper function plus 1 again?
Yep. So our outer radius should be 1 plus x squared plus 1, or 2 plus x squared. And what should our inner radius be? Our smaller radius should be?
Just, oh wait. It'd be the function of the lower one, so root x plus 1, right?
Yep, 1 plus root x. Everybody agree that those are your two radii?
Yep.
So 2 plus
Yeah.
x squared squared minus 1 plus root x squared dx. All right. And what if I was revolving it around some line up here? Let's say y equals 4. What would my outer radius be if I was going around y equals 4?
-4 plus x squared plus 1.
That would,
Oh, wait, no.
no, we got to look at our lower function now.
Yeah.
4 minus this y.
4 minus root x. Okay.
This is the height of root x, so it's 4 minus root x. And what should our inner radius be?
4 minus x squared plus 1.
4 minus the quantity x squared plus 1, which would be, what is that? 3 minus x squared. And so this one should be pi times an integral from 0 to 1 of 4 minus root x squared plus 3 minus x squared squared. Conceptually, everybody okay with all of that?
Yeah.
All right, cool. I will expect that you can set up and evaluate integrals that have easy integrands between two regions going around any horizontal line then now. So that brings us back to this question that I originally was planning for us to look at. The region bounded by this y equals 3 square root x over 4, the x-axis, x equals 4. And we want to revolve it, this time around the line x equals 4. So if I revolve this region around x equals 4, we're going to get sort of a three-dimensional thing that looks like this. It's like a little chocolate chip or something. How it looks like, yeah? Everybody agree with that? Looks kind of like a chocolate chip. Everybody okay with that being what it sort of looks like there? I hope.
Yes.
All right, and when I slice it vertically, what do I get?
Slice.
A slice.
Yeah.
You get something, right?
dx, right? You get dx.
I get something with dx, yeah. What does it look like?
Kind of like a half circle.
Wouldn't it
Yeah.
just be a circle?
Looks like something weird.
Is it
Not
like a
some regular
parabola?
shape.
Like
Oh,
the
yeah, it's
flattened
a
like
parabola,
Hershey's
right?
Kisses.
Yeah. Instead, it doesn't look like a circle. It looks like something, it's got a flat bottom to it. Not even, it looks weird, right?
Like the conic sections, right? It would be like a parabola or something.
Yeah, something, it would be like that, but not that. And that's a problem, right? We need to have a regular shape. So how can I get a regular shape by still slicing this?
Would you have to revolve it around the x-axis and then divide the volume by 2?
Well, we're not going to revolve it around the x-axis now. No, that's way too much work.
Okay.
Make a slice that's perpendicular to y.
Yeah, make a slice this direction. Right, if we slice it this way, and I open it up, it should look like a circle, but it should be a circle with a thickness of dy. Everybody agree with that?
Yeah.
Yeah.
All right. So what variable do you think we should integrate in?
Y.
Probably in terms of y, which means, well, we're going to have to figure out what is the lowest value of this region. What's the
0.
lowest value? Yeah. And what's the largest value of this region?
3.
3. Put this point up here. And it's going to be pi times the radius squared. Well, my circles look like this, right? As we go out, they're getting smaller and so on, right? A bunch of different little circles going up there. Their radius goes from 4 to some value over here. Right? What is that radius? It's this,
Would it
right?
just be,
I mean,
yeah.
depending on how I draw the line, that's my radius.
So would it be, what x equals when you, or never mind.
Isn't
It
it?
wouldn't be x. This whole thing is 4. What's the little leftover piece here?
The equation y equals 3 square root x over 4.
It's the distance, right, from here to here, which is just an x distance, though, isn't it? Right, we measure
Yeah.
x from the y-axis going to the right.
So it's just 4 minus x.
So our radius should be 4 minus x. So I want 4 minus x squared in here, dy though. And so the dy creates a problem for us. So what do we need to do with that 4 minus x?
Use our equation to turn it into y.
So if y equals 3 root x over 4, that should give us y over 3 equals root x over 4, or y squared over 9 equals x over 4, or x equals 4y squared over 9. So this should give us 4 minus 4y squared over 9 squared dy. That makes sense to everyone?
And then we would never have to like solve that by hand, right? Or would we ever have to do that?
Of course we would. Let's do it right now.
Okay.
So what should that turn into? It'd be pi times the integral from 0 to 3, and we had what, 4 minus 4y squared over 9 squared. So that would be a 16 to start with. And then this would become a negative 32y squared over 9. And then the last term there will become a plus 16y squared over 81. Everybody agree with that?
Don't when you multiply the y squared together, they become y to the fourth, or?
Oh yeah, sorry, why did yeah. Good or no?
Yeah, yeah.
All right, so now we integrate. 16y minus 32y cubed over 27 plus 16y to the fifth over 405 from 0 to 3. Nice thing is that when we plug in 0, it's all going to come out to be 0. So really, we just got to plug in the 3. That'd be 48. 3 cubed is already 27, right? So 27 over 27 will cancel. And here, we already had an 81 here. 3 to the fifth is 81 times 3. So I could have canceled out that 81 with the 81 here. So I should end up with 48 over 5. And what does that simplify down? That should be 16 fifths, or 16 times 5 over 5, I mean, should be what, 80? So 80 fifths plus 48 fifths should be 128 pi over 5 units cubed. And yes, you should be able to do that integral. Any questions there?
No, not really, no.
All right. Let's do another problem. Let's take y equals root x and revolve, let's say from x equals 0 to x equals 4. Actually, let's not do y equals root x. Let's do an easier one. Let's do y equals x squared. From x equals 0 to x equals 4. Let's do this around the y-axis. So thoughts on how we should set that up?
Like revolve it and show the 3D shape. Just so we can get a visualization of what's happening.
Sure.
Cool. And then we'd have to slice it so that it's dy.
Exactly. So anytime we're going to revolve around a vertical axis, we have to slice it in terms of y. So what should we do?
Do what we did on the last problem.
That should be
Same
pi.
process.
If we're going from x equals 0 to x equals 4, what's my lower limit going to be?
0.
What's my upper limit going to be?
16.
16, exactly, because we're going to x equals 4, means we're up here at y equals 16. And since we're going to slice it horizontally, it's going to have to be dy, and so we have to use y values. And what's the radius of one of these pieces? Well, it's just the value that we've gone over in the
X. It's
x
just
direction. And if, well, we'll say r equals x, and if y equals x squared, then x ought to be root y. Yeah? Everybody agree with that?
Yeah.
So it's root y squared, or just y. So we should have pi, and like we said, root y squared is just y, so the integral of y is y squared over 2 from 0 to 16. 16 squared is 256. Half of that is 128. Minus 0 should be 128 pi. Good or no?
So there was no like outer radius, inner radius thing there because it wasn't a washer, right?
Correct.
It was just a circle, okay.
Right. The region that we were revolving around that axis was fully pushed up against that axis.
Okay, makes sense.
But for this one, which is the one I was about to do a second ago, and then I changed my mind, y equals root x. From x equals 0 to x equals 4 around the y-axis. So if we revolve this around the y-axis, we're going to get something that sort of looks like that. Three-dimensional little, I don't even know what you would call that thing. Right? But something that looks like that. And if we slice it this way, what do we get?
dy.
We get dy, and what does it look like?
A washer thing.
Looks like washers, right? Because now we don't have the region that we're revolving around the y-axis is not fully pushed up against the y-axis. We end up with a washer again. We get a circle with a hole in the middle of it. So we know it's going to be pi. We know we're going to integrate from the lowest value, 0, to the highest value. What's the highest value up here?
2.
Integrate from 0 to 2. Well, our outer radius extends from here always over here to x equals 4. So what's that total distance?
4.
Should be 4. So our outer radius is 4. What about our inner radius?
4 minus our function.
Our inner radius would be from here to here for the cross section that I started to draw, wouldn't it?
Is it just x?
That distance is just x, which is y squared. So if that radius is y squared, it should be y squared squared dy. Good or no?
Good.
Okay, so now we've just got pi times the integral from 0 to 2. 16 minus y to the 4th dy, or pi times 16y minus y to the 5th over 5 from 0 to 2. Plugging in 0 is easy, becomes 0, right? So it's just pi times 32 minus 32 fifths. And 32, if I write that with fifths, should be 160. 160 minus 32 ought to be 128 pi over 5, which we'll note is similar to the last.
Same as the,
Not quite the same, right? This one was 128 pi, so 128 pi over 5. If we had gone from r equals, if we got from x equals 0 to x equals 16 here, we would have got the exact same value. We would have got 128 pi.
well, it's the same answer as 2 problems ago.
Oh, is it?
Yeah.
Oh, yeah, it was. Yeah. Interesting, because that's a different function altogether. So that's just a coincidence.
So for the parabola one, would they specify if they wanted us to revolve the area underneath the curve? Or just like, I guess the area between the curve and the y-axis?
Yeah. I think I said revolve the, maybe I didn't say that. I probably should have said that. Revolve the part between the y-axis
Okay,
and the function. Yeah. Because if I was just saying revolve, if I was just saying to revolve the region between the parabola and the x-axis, that's a totally different problem, which we could do. Right.
yeah, it's like the root x one I just did.
Yeah, exactly. Similar to that one. Yeah. Yep. So sort of get the idea of these. Should we do some more? Let's do some more. Let's take, how about, let's take the region from 0 to pi of sine x and revolve it around, nah, that's not just, let's do, what should we do? Let's do the e to the x function. Do e to the x from, let's say, from x equals 0, x equals 1. So just this little bit here. And let's revolve it around x equals 2. Yeah, that sounds good. Let's do that. We'll revolve the region underneath e to the x from x equals 0 to x equals 1 around the line x equals 2. So going around this line, we're going to get something sort of like this with a hole through the middle of it, which when we slice horizontally gives us dy and it gives us washers, right? Everybody
makes
agree?
sense.
Yeah. Okay. So we'll need to integrate from the lowest part. What's the lowest part of this?
0,
0.
0. To the highest part of it,
e,
E.
would be e, right? We're going to x equals 1, that'd be e. It should be the outer radius minus the inner radius. Each one squared, right? So what's our outer radius?
So just
2.
4 or 2, yeah, that's the diameter, my bad. 2.
Okay, yep. It's not always 2 because sometimes our outer radius is up here, right? It's not always,
Oh yeah.
Oh, yeah.
right?
So it's 2 minus x.
Yeah, the whole thing is 2, but it's 2 minus that little x piece. Exactly. So our outer radius is 2 minus x. What's our inner radius?
One. Or no. Wait. Yeah.
Yeah,
Oh,
it's just
I
1.
guess myself. It's just 1.
This one is always, the right-hand portion of our region is always bounded by this 1 here, right? But the rest of it here, sometimes we're not all the way over here, right? Now, we've got a little bit of an issue here too, though, is that well, let's think about this here. What does x equal?
What do you mean? What is x equal?
Well, we're going to have to do this in terms of y, right? That's what we said.
Oh.
Maybe dy.
The
So what is
natural log of y.
Natural log of y.
x is equal to the natural log of y. Yeah, everybody agree with that. But if we're doing this in terms of y values, as
You
we
can't
go
plug
up,
in 0.
right, as we go up here, we can't plug in a 0 value, right? And so we're going to have to do something a little different with this one. We can't just go straight from 0 to e, because we should now hopefully note, as somebody, I don't know who it was, but somebody wanted us to make our outer radius 2 to begin with. Well, that's accurate for a little bit of the time. From 0 to 1, right where this crosses, the outer radius is 2. And the inner radius is 1. But from 1 to 2, our outer radius is this 2 minus, not to 2, to e. Our outer radius is 2 minus x. But our inner radius is still 1. Does that make sense? So from 0 to 1, our outer radius is 2. No matter what, it's 2. But as we move up, it now is this x value as we start to move away. Does that make sense or no?
Yeah.
And since we haven't yet come up with a way to integrate natural log, you'd have to use a calculator to evaluate this. But we can just call that good for now. We don't need to. The first one's easy, right? I mean, this is just 3. We did up a 3y, and the first part would be 3 pi plus whatever this integral is. Any questions on what we're doing here with any of these types of problems?
Where did you get the e from for that second integral?
That's the highest y value that we hit in our region. So if we're going from x equals, we said x equals 0 to x equals 1, right? So if we go to x equals 1, the y value is e to the first power, or e. That's the highest point of our region, is x equals e, or y equals e, sorry.
Okay.
Does that make sense or no?
Yeah.
Can you explain one more time, like quickly, why we had to split it up into 2 different integrals?
Yeah, so there's sort of 2 reasons here. I mean, the bigger reason is that we're doing this in terms of y. And so we have to look at what is the outer radius. And the outer radius is 2 for a while, no matter what. It's always 2 from 0 to 1, as we go up here to 1, where this intersects through the y-axis. That outer radius is always these 2 full units. But as soon as we go above 1, that outer radius starts to change. It's no longer 2 units, it's 2 minus however far over we've gone on our function. Does that make sense or no?
Kind of.
Right, I mean, this is what that region looks like, yeah? And so all the way up here until we get to 1, we've got just a straight vertical line, right? We just have this nice little rectangular.
Got it. That
little
makes sense.
But
That drawing
the
helps.
further up we go from 1 to e, now that radius starts to change.
Yeah,
Cool.
that works. Thanks.
Perfect. Any other questions?